So the question is, like this, what will be given to you is a n value. Let us assume the n value given to you is 2. Now what you must understand is, 2 means what you have to visualize is 2 opening brackets is given to you, 2 closing brackets is given to you. Now what are all the valid combinations that you can write using these 4 brackets, 2 opening, 2 closing? What I mean to say is, valid means for every opening there should be a corresponding closing, which means one way to write it is, one valid combination is like this. So opening followed by closing, opening followed by closing. This is one valid combination. The second valid combination is open, open, close, close. This is also a valid combination. Don't think there should be space here, just so that it is clear to you, I have written like this. Open, open, close, close. Open, open, close, open, close, open, open, close, close. Would you agree with me? Is there any other valid combination that I can write? Tell me, is there any other valid combination I can write? No, I cannot. How will you write? How will you be able to think? Similarly, let us assume the n value given to you was 3. Let us assume n value given to you was 3. So for example, like this, n value is 3. 3 means 3 opening brackets are given to you. 1, 2, 3. 3 closing brackets are given to you. 1, 2, 3. What are all the valid combinations? First valid combination is like this. Open, 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 close, close, close. Would you agree with me? That is what I am also showing. The next valid combination can be like this. So open, close, open, close, open, close. The next valid combination can be open, open, close, close, open, 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 close, because that's all you have, open, close, because 3 opening, 3 closing. Next valid combination is open, close, followed by open, open, close, close. Would you agree with me? Is there any other combination you can write here? No. 1, 2, 3, 4 combinations. Tell me, is there any other combination that you guys can come up with? Put in the chat. Yes or no? Is there any other combination possible? Not possible. So now I hope you understood the question. The question is, okay, so obviously there is one more combination possible, which is, so you keep saying no, you will misguide me, you are enough to misguide me in my life, you know. Okay, 1, 2, so open, 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 close, open, close, followed by close. So see, 1, 2, 3 opening brackets, 1, 2, 3 closing brackets. So there are 4 combinations. So you must write a program wherein at the end of the program, given an n value, all the combinations are printed on the screen. 1, 2, 3, 4, 5, all combinations are printed on the screen. Hope you're able to think. So totally there is 1, 2, 3, 4, 5 combinations. Hope you're able to think.
One student is asking the previous question, if the k value changes, how will it work?
So some of you are personally texting and asking, in the previous Josephus problem, if k value changes, will our logic change? No, definitely not. It will work for any k value. That is the beauty. It will work for any k value. You want proof? Let me execute and show you. So k was 3, right? Again, I'm sorry, I just cut this short and I'm going back, but let me go back. So if I just re-execute it, then n is maybe 10, 2 is the killing factor. If I press enter, right position is 4. You go calculate, put 10 people in a circle, 1, 2, kill, 1, 2, kill, 1, 2, kill, 1, 2, kill. Like that you keep going, you will see the 4th position is the right place to stand. Of course it will work, because that's the beauty of mathematics here. If it works for one thing, it will work for everything. Any confusion till this point of time, guys? Okay, great. Anyway, so let me just remove this. Coming back to this problem, wait. Again, sorry to get distracted. Is this clear? Is this clear to you? Given n value, print all the valid combinations. Now, I would tell you that these are the kind of problems which a recursive approach will work beautifully. Try to come up with a recursive program for the same.
Does this string given?
Only n value will be given to you, nothing else. Only n value will be given to you. If n is 2, you must write your code in such a way that you are assuming that there are 2 opening brackets, 2 closing brackets. 3 means 3 opening, 3 closing, and you have to print all valid permutations. So these are the kind of questions which you must solve if you want to get placed in really good companies with very good packages and you want to grow in your career. Now use your brain. Every time I give you 2 minutes, this time I'm going to give you 5 minutes time. Think, at least think, use your brain. Let me try to explain, okay? Listen and try to understand carefully. See now, first and foremost, what I would do is, I want you to recursively think, right? So obviously recursion means there should be a function. So what I will do is, initially, I will create a function, and this function is going to be such a function which, like this. Now let us assume n is equal to 2. Okay, this is too small. I'll increase the size because, you know, I don't think you'll be able to see it. Okay, I can bring it somewhere in between. On top you take it here. Yeah, fine. Okay. Now guys, I hope everybody can see it. See, if n is equal to 2, these are the valid combinations, right? Okay, keep that at the back of your mind. Now, I will create a function, guys, like this. I'm going to create a function. In this function, what I will do is, I am going to have basically an array whose size is 2 times the n value. Now you may ask why. Because if n is equal to 2, what does it mean? 2 opening brackets, 2 closing brackets. Whichever may be the combination, don't you think the total size will be 4? If you agree with me till this point of time, put a yes. Why this should be n into 2? Put a yes. That much is clear to you? Beautiful. Initially this array is fully empty. And what type of an array is it? Not an integer array, not a floating point array. It is a character array, because after all these are characters. Okay. What I will do is, obviously array means these are the index values 0, 1, 2, 3, and maybe I will also have n. Also, I am going to have 2 variables, one called as O and another called as C. So see, I don't know if you guys are, you can make it a little bit more bigger. Yeah, just make it bigger. Yeah, yes. Okay, yeah, bring it down a little bit. Yes, okay. As you guys can see, I'm going to have n value. I'm going to also have another value called as I. Initially I is 0. Why I? Because I is going to keep track of the position on my array where a bracket has to be put. Should a bracket be put in the 0th position, 1st position, 2nd position or 3rd position, I helps me track. N is anyways given to me. I hope I'm clear. Next I'm going to have 2 more variables called as O, whose initial value is going to be 0, and C, whose initial value is going to be 0. I hope I'm clear. This O and C is what is going to help me decide whether to put an opening bracket or whether to put a closing bracket. Now you may be wondering how. Very simple, guys. First and foremost, when the first time the function is called, I have created an array whose size is double the value of n. Now, in the first character, I is at the 0th position, so I am showing I there. At the first character, I need to put a bracket. Now tell me, the first time, should I be putting an opening bracket or should I be putting a closing bracket? Whichever be the combination, should I put opening or should I be putting closing? common sense it is that always it is going to be opening, right? But I have two options with me. The two options are, option 1 is to put a opening, option 2 is to put a closing. These are the two options. But to select which option, opening or closing, what I will do is, I will write code in such a way that first it will always see if opening can be placed. If opening cannot be placed, only then it will look for closing. Oh really sir, will this work, you may ask. And how sir, how will you do? Simple thing. Inside this I will put a condition. To put opening bracket, I will check if this opening O value, is it lesser than n value, I will check. So see, O less than n, I will check. Or if opening is not possible, I want to check if closing can be put. For closing, I will attach a condition, is C less than O, which means is the closing count less than opening count. Now you may be wondering, how will this work? Let me trace it for you. Now we are doing recursion, which means we want to keep breaking it down into smaller and smaller and smaller problems. So what I will do is, watch it carefully. If in case I enter this function, I create an array which is double the size of n, then I will come and I will check my first condition. Is O value less than n value? O value is 0, n value is 2. Is O less than n? Yes, it is true. I am making it green to know that it is true. If it is true, what I will do is, I will insert at the ith position an opening character. So see, at the ith position, I will be inserting an opening character, or opening bracket. I will insert, which is what I am also just showing you. So see, I'm very sorry, it became too fast here. I will again call the same function, where at the ith position, I have inserted an opening bracket. Now I should move forward. If I should move forward, I value I will increase by 1 and send. So see, I plus 1, I will become 1. Next, you have put an opening bracket. O is there to keep the count of opening brackets, and you can clearly see O has become 1. O plus 1 I have sent. So I inserted an opening bracket, moved I one step forward, and I have incremented the count of O. I hope you are able to think. Again, whenever you call, two conditions will be there. Can opening be put? Can closing be put? Opening condition is O less than n, closing condition is C less than O. Now first always preference is given to opening. So first I will check, is O value 1 less than n? Yes, it is less. Condition is true. If condition is true, then I am making it as green. If it is green, then I am again going to call the same function. But this time at the ith position I will put a opening bracket. Now I should move forward. So see, I will move forward. After I moves forward, I value should increment. So see, 1 has become 2. 2 opening brackets I have put. So 0 becomes 2. Any confusion till this point of time? Yes sir, we understood till here. Next what, you may ask? Next what means, now again recursively I am checking at this position. So see how what we are doing is, instead of directly seeing what are the brackets you can put, you are taking one character at a time. Here which bracket can I put? Here which bracket can I put? Here which bracket can I put? Next here which bracket can I put? Character by character you are breaking it down. Okay, now I am saying which character can be put. Opening I can put, closing I can put. Opening condition, is O less than n? 2 is not less than 2. First time condition will fail, which means I will not put opening bracket. I will come below and I will check, can I put closing bracket? C less than O. C value is 0. 0 is less than O. Yes, O value is what? 2. Closing bracket count is lesser than opening bracket count. Condition is true. If it is true, at the ith position, I would like to insert a closing bracket. So what I will do is, I will insert a closing bracket, again call the same function, move I forward, I plus 1. Because I put a closing bracket, C value I will increase, C plus 1, see it has become 1. Again I will check. Now in this character, in this place what can I put? O less than n. Can I put opening bracket? No, condition will fail. C less than O is C value is 1. Is 1 less than 2? Opening bracket count true. If it is true, I am going to be putting the closing bracket. So see, I will put closing bracket, and what will I do? I will put closing bracket and recursively again I will call. Closing bracket has been put. Whenever you call recursively, you will increment I value. Now I value increments, it goes outside. C value I will increase and send. C value becomes, from 1 it became 2. Now tell me, should I proceed or have I hit my base? If you think I've hit my base, put base in the chat so that I know that we have hit the base. Yes or no? Base. I've hit the base. If I hit the base here, it means I should not recursively proceed. And how will I know I've hit the base? See, I value has become 4. The length of this array is 4. When I becomes equal to the length, I know I have hit my base. I know I value has gone out of the boundary, because index, the last index will always be length minus 1. So if I has become length, I know I have hit my base. Once I have hit my base, what should you do? No need to return any value. Control you have to return. Value need not return, because the problem is to print. So see, whatever is there in this array, I will print it as it is. I will print it. So if I print this array, I will get this. This combination I will get. That is what. Again, obviously, all these conditions will fail. But anyways, that condition will not even be checked because we have hit the base condition. But I will print it. After I print it, this is my base condition. So after printing whatever is there in this array, control will return. When control returns, think. This is where all your brain cells, you have to give it to me. Control was returned. Now, this statement is already over. You are in this statement. This statement executed. Is there any more statements below, any more conditions? No. No means it will return. Again, this statement executed. It was false. Then this statement executed. Now, this statement is over. No more statements below that. So, control will return. But when it returns this time, tell me, will it return back above or will the next statement execute? Tell me, will C less than 0 execute or will it return? If you think return, tell return, otherwise tell C less than 0. What do you think will execute? Only 3 people are answering. What about others? Think. Absolutely right. Because guys, in this function, this line is over. After that, this line is there. When you return, it will return back to where the control stopped, where the execution stopped. Execution stopped here. Now you will come down, check this. When you check this, is C less than 0? Oh yes, C is less than 0 because C here is 0, O is 1, 0 is less than 1. Now this condition becomes true. If it becomes true, it means insert closing bracket. So at this position, I will insert a closing bracket and again I will recursively call. I hope you are able to think. See, closing bracket I put. I will move forward. So I is 1, I becomes 2. Closing bracket you have put. C was 0, C becomes 1. I have incremented C value and sent. If this condition is satisfied, I plus 1, O plus 1. If this condition is satisfied, I plus 1, C plus 1. I hope you are able to think. Again you are here. Now what to put in this place is the question, isn't it? Again check. Can it be opening? For opening, O should be less than N. O is 1, N is 2. Yes, I can put. Which means at this position, at character at this position, or not character at the index here, I will insert opening bracket like this and I will again call it. This time see, opening bracket I put. I has to move forward, so I will increment. 2 became 3. O, opening bracket I put. So O was 1, O becomes 2. Now here again check. Can opening be put? Closing be put. Always first check opening. For opening to be put, O value should be less than N value. But you can see O is 2, N is 2. Condition fails. If condition fails, there is one more condition below it. Now this will execute. C is 1, O is 2. C is less than O, yes, condition is true, which means I can insert a closing bracket, and hence I will insert a closing bracket and I will recursively call. See, closing bracket I put. Obviously, I you will increment and send. What else will you increment and send? C, because you have incremented you have put a closing bracket. So see, I becomes 4, C becomes 2. But if I becomes 4, I goes outside. If I goes outside, it means I values become equal to the length value, which means I've hit the base condition. None of these conditions will anyways be checked. So because it's the base, because base we will write above all conditions, and hence the moment you hit the base condition, what you have to do is whatever is there in that array, print it as it is. If I print this array, this combination I will get. Any confusion till here? So the first base when you hit, the first leaf gave you this combination. The second leaf gave you this combination. If n was higher in value, more leaves you would have got. All combinations you would have got. Here only 2 combinations are there. After which duty is done, return. Now tell me, what executed? This, no more statements, return. Now tell me guys, will it return or will C less than O execute? I am seeing if you are alert or not. Which one will execute? Return or C less than O? See, if something did not execute, it is always white. If something executed and it was true, it is green. If something executed and it was false, it is red. So you can see this executed. See, O less than N means at this position you inserted an opening bracket, right? But you did not check for closing. So when you come here, this is still remaining. I will check this condition. No, not possible, because C is not less than O. Because C is 1, O is 1. They are equal. They are not lesser. Lesser means false. Now it will return. Correct. Ultimately it has to return. But I was just checking if you are able to trace the program correctly. And here also I will check if C less than O I will check. And definitely, I mean here also nothing like that. So anyways, this is also done. So I will return back to the original. I hope I am clear. And here I will check C less than O, not possible. Closing is not possible because naturally the first character can never be closing. Condition wise also it will fail. I hope you are able to think. So finally it will return, execution will get over. At the end of it, one leaf gave you the first legit combination, second leaf gave you the second legit combination. Now comes how to write the recursive condition, because you can notice, if you notice, every time you call a function, if this condition is satisfied, you have to again call it, but with certain changes. If this condition is satisfied, you should again call it with certain changes. So I just want to show you how to write the recursive thing. So I'll just bring it back to its original size. Fine. Now I'm showing you that recursive thing. Okay, now watch it. You can call it anything. I'll call it as balance parenthesis. I'll call the function as balance parenthesis. So this is how I would like to recursively write. Listen and understand carefully. Balance parenthesis. I will send it an array whose size is double the n value. I will send it the n value. I will send it actually n value is optional because we are not really using the n value anywhere. We don't really require it. I value, O value, C value, opening count, closing count. Now the thing is, whenever you call, first one condition is checked. What is the condition? 2 conditions. The first condition is, can I put opening bracket, O less than n? If I can do it, then what I will do is, at the ith position, I will insert an opening bracket. See, AR of I equal to, within single quotes, opening. Then I should again recursively call it. But this time, I should move forward, opening value count should increase. So that is what I am also writing. See here, AR, n is the same, I plus 1, O plus 1. I don't know if this plus is visible to you guys, but I plus 1, O plus 1. Any confusion till this point of time? That is if opening is possible. If this was not possible, below that there is one more condition. Below that there is one more condition, which is what I am writing, which is if closing is possible. If closing is possible, at the ith position put a closing bracket. Then same function only you call, but I should move forward, closing value, C value should increase by 1. So see, balanced parenthesis of AR, N is the same, I plus 1, O, C plus 1. Any confusion till this point of time? How many of you understood this perfectly? And please understand, at any point of time, only one of them will get called. Both will not get called. Only if this condition is satisfied, this will get called. If this is satisfied, only this gets called. At the same time, both will not get called. I hope you're able to think. Anyways, now tell me whether you understood this properly. If you can just drag it and keep it to the side so we can write the code. I'll just keep it somewhere here. Yeah, keep it there enough. Yeah. So now let's write the code for this. Okay. So much explanation, but code is simple. Reduce Josephus. I'll come down. Yeah, I mean n value was there. Undo it. Yeah. N, K you can remove. Remove that also. See guys, n value I have taken. The moment I get n value, first thing is I must create an array which is double the size of n. So I'll tell new int. Character array it is. Because what we are putting is characters. Size is n into 2. I'll give it a reference, I'll call it as AR. AR is a character array or an array of characters. Okay, super. Now let's go first define the function. So I'll go here. Again, I told you there's no need to send n to it anyways, but okay, actually n is required because we are checking O less than n, so it is absolutely required here. Sorry, I said n is optional, but 100% is required. That's how we are checking if opening can be put. Anyways, I will tell whatever static. It doesn't return anything because it prints void and balanced para, bal para. And what it accepts is an array AR, so character array AR, then n value, I value, and O value, and C value, correct. Inside that, first I'll write my base condition, if in case. And what is the base? Base is when I goes out of the boundary of the array. And when it goes outside the boundary of the array, I value and length of the array will be same. So I'll tell if in case I is equal to AR dot length, I've hit my base. If that is the case, what I should do is, all I have to do is print the array. If you recollect, what were we doing? Printing the array. So I will tell system.out.println and I will just tell AR. Now some of you who are not revising will have a doubt. Sir, array, how can you directly print, sir? If this was an integer array, we were never directly printing. If it was a floating array, we were never directly printing. Correct. But this is a character array. Character arrays can be printed directly because system.out.println will convert that array of characters into a string and print it automatically. You don't have to do anything. So here I can directly print it because this is an array of characters. Otherwise, arrays have to be used with loops. Please don't get confused. Did you understand why I am printing this directly? Put a yes in the chat if you understood. Put no if you did not understand. Super. So where was I? Base condition is done. Now come down. Now that base condition is done, now comes our checking. Can opening be put or can closing be put? So see, if O value is less than N value, then inside that I will come, and what I will do is I will again call the same function. So again I will call the same. You do one thing, again call balance parenthesis. Oh wait. Before calling, press enter after the bracket. Here. Yeah. The moment you know you can put an opening bracket, first you must put an opening bracket. How will you put it? Whatever is I value, at that position assign a character which is an opening bracket. So I will tell AR of I, please make it as an opening bracket. Then again I want to call. When I call, what I will do is, array is the same, n is the same, I should move forward, I plus 1. I inserted an opening bracket, count of opening should increase, O plus 1. That is what I have also told you. If this condition doesn't satisfy, I will come outside. I'll check, can closing bracket be put? How will you check that? C less than O. If in case C less than O. Then I will come inside, and what I am going to do here is, the moment you know closing bracket can be put, first thing is put a closing bracket. So I will just tell at the ith position in the array, please insert a closing bracket character. Then again recursively call. So I will tell balance para. Okay. Array is same, n is same, I should move forward, I plus 1. Count of closing bracket should increase, C plus 1. That's it. That is it. If you hit the base of recursion, you will print the array because you would have filled all characters. I would have gone outside. Otherwise, keep inserting, recursively calling, recursively calling, recursively calling, recursively calling. How many of you understood this perfectly? Put a yes in the chat. Okay, beautiful. Now we have to of course call it, so I'll just come down and system dot not system dot out dot println, because it will anyways print. You just have to call it balance parenthesis, and I will pass arn, and see I value initially should be 0 because array index starts from 0. Opening count value is always 0. Closing count value initially is always 0. I hope I'm clear. That's it. Now let us go and see whether this works. Now this is the moment of truth. Let's see whether all this explanation works. So I'll go and I will compile it, in which case no error. I will execute it. N value. First let us see, n value is 2. If I press enter, oh perfect. Clear the screen. N value is 3. Press enter. Perfectly it works. N value is 5. Oh my god. Okay. So many combinations. Perfectly it works. Now guys, you can't keep increasing this n value because you are using the most inefficient thing for the memory, which is recursion. Imagine how many calls, how many stack frames, how many n variables, I variables are array. Anyways, it will be referring to the same thing because of you're passing by reference. Again, if you understood that, then you're revising. Otherwise, God bless you. But point being that array will be common. Everything else duplicate copies, I value, O value, C value, how many calls. But for the programmer, solution is how many lines of code? Let me just take you back to the program. For programmer, writing recursion is so easy, after all, for such a nice problem. 1, 2, 3, 4, 5, 6, 7 lines of code, done. Balance parenthesis, done. Now, in an interview, if you can write this code and you can trace and explain, you will be in a different level altogether. Okay? Alright guys. So, I hope till this point of time, whatever I spoke is crystal clear to you.